Trees play a significant role in reducing erosion and moderating the climate. It stabilizes the soil, prevent rapid runoff, rainwater, and help prevent desertification. And it can also have a role in climate control, in help in the maintenance of biodiversity and ecosystem balance. Tropical rainforests are among the most biodiverse habitat in the world. Rainforests as well as endemic forests, species are rapidly disappearing due to deforestation, the resulting habitat loss and the pollution of the atmosphere. Biodiversity studies aim to improve the information available for the decision makers in protected areas through collecting data on natural biological resources present to certain area and making known their utilization. The focus is on identifying trends in biodiversity and its use as to guide action in protected area management. The study intended to improve the participation of protected area communities in protected area management. Number 1, what are the different species of forest trees present in the northeastern slope of Mount Arayat? Number 2, what is the distribution and occurrence of the forest trees in terms of the following diversity indices in the northeastern slope of Mount Arayat? A. Frequency. B. Relative frequency. C. Dominance. D. Relative dominance. E. Density. F. Relative density. And also G. Species diversity. Number 3. How is the distribution and occurrence of the forest trees in the northeastern slope of Mount Arayat, being affected by altitude, humidity, air temperature, and the following endemic factors? Letter A. Soil pH. Letter B. Soil moisture. Significance of the study. This study would provide a starting point of data for students who will also be dealing with the same field of the study. This study will also advocate proper conservation and management of natural resources, especially forest trees, which are very important in flood prevention. Scope and delimitation. This study was limited in the inventory, collection, identification, and classification of the different species of forest trees distributed in the northeastern slope of Mount Arayat. The relationship with the different ecological factors such as altitude, humidity, air temperature, soil pH, and soil moisture. The diversity indices such as frequency, relative frequency, density, relative density, dominance, relative dominance, and species diversity were also noted.
Research design. In gathering the needed information and data of the study, descriptive survey method was applied. Research procedure. A. Establishment of the study area. B. Physical description of the study area. And C. Data gathering procedure. A. Establishment of the study area. The study area was established in northeastern slope of Mount Arayat. Fixed area cluster method was used in establishing the study area. The study area was consist of one cluster with 4 subplots and one main plot as a basis to establish the location of the area. The plots measured 5 meter by 5 meter and the distance between subplots was 5 meter. The subplots were established by measuring 5 meter distance from the main plot at around 45-degree angle. Physical description of the study area. The following descriptions of the study area were given respectively. The cluster was divided into 4 subplots and 1 main plot. The subplot 1 was located 73 meters above sea level. It was inhabited by many callos and it has a dark environment since callos, big trees, thrive on this area. The subplot 2 was located 78 meters above sea level, while the subplot 3 was located 76 meters above sea level. The subplot 4 was located 71 meters above sea level. Many shrubs and other plants inhabited this area. The main plot was located 74 meters above sea level which has dark environment since there are other big forest trees around this plot. C. Data gathering procedure. Number 1. Ecological factors. Ecological factors such as altitude, humidity, and air temperature were gathered and documented in a record book. Number 2. Collection of specimens. The specimens were collected once. Picking of the leaves and stem was done. With the use of a record book, all of the species collected are recorded. Number 3. Preservation procedure. The specimens that were collected were preserved using a herbarium presser. The device was made up of wood material and a pair of webbing or anything that can tie the boards. The specimens were covered with newspaper in order to preserve. All the collected and gathered specimens were properly pressed and dried for longer preservation. Number 4. Identification procedure. The different species of forest trees in northeastern slope of Mount Arayat were initially identified using the following morphological characteristics. A. Length of leaves. B. Shape of leaves. C. Leaf arrangement. D. Leaf attachment on stems. E. Leaf color. Population diversity analysis. The quantitative data needed were gathered and computed using frequency, relative frequency, density, relative density, dominance, relative dominance, species diversity, and importance value.
In this study, there were 8 species of forestry collected in the northeastern slope of Mount Arayat. They were identified and classified as follows. First, Stradus asper, Muraya paniculata, Semicarpus coniformis, Coleohevia hospita, Leucaena leucocephala, Bambusa vulgaris, Molotus philippinensis, and the lastly is Samanea saman.
Distribution, occurrence, and population diversity analysis of the forest trees present in the northeastern slope of Mount Arayat. Table 1 shows the distribution and occurrence of the forest trees present in the northeastern slope of Mount Arayat. Strabelus asper from Moraceae occurred in all plots, with a total of 51 saplings. Muraya paniculata from Rutaceae family occurred in plot 1 with a total of 2 saplings. Semicarpus cuneiformis from Anacardiaceae occurred in plot 2 and plot 3 with a total of 3 saplings. Plainhobia ospita from Statuliaceae occurred in plot 2 and plot 3 with a total of 5 saplings. Leucaena leucocephala occurred in plot 2 and plot 4 with a total of 12 saplings. Bambusa vulgaris from family Pabustan occurred in main plot with a total of 1 saplings. Molotus philippinensis from Euphorbiaceae occurred in plot 3 with a total of 4 saplings. In terms of occurrence, Strabelus asper got the highest occurrence with a total of 100%, while Muraya paniculata, Bambusa vulgaris, Molotus philippinensis with the percentage of 20, and Semicarpus cuneiformis, Plainhobia ospita, Leucaena leucocephala with occurrence of 40%. Distribution and occurrence in terms of seedlings. Strabelus asper occurred in plot 1, plot 2, plot 3, and plot 4 with a total of 44 seedlings. Muraya paniculata occurred in plot 1 and plot 3 with a total of 5 seedlings. Semicarpus cuneiformis occurred only in plot 3 with a total of 4 seedlings. Plainhobia ospita occurred in plot 2 with a total of 1 seedlings. Leucaena leucocephala occurred in plot 2, plot 3, plot 4 with a total of 201 seedlings. Samanea saman occurred in plot 3 with a total of 3 seedlings. The species Travelus asper and Nucaina leucocephala obtained the highest occurrence of 60% since it occurred in 3 plots, while Murraya paniculata obtained the occurrence of 40% because it occurred 2 plants. Semicarpus cuneiformis, Kleinhobia oscita, and Samanea salmon got the lowest occurrence of 20%. In addition, Table 2 clearly shows the computed population diversity analysis of the forest trees present in the northeastern slope of Mount Arayat. Among the 8 species of forest trees that were identified and classified in the research, Travelus asper obtained the highest frequency of 1, while Murraya paniculata, Bambusa vulgaris, and Molotus philippinensis obtained the lowest frequency of 0.2. The highest relative frequency was attained by Travelus asper, having 285.714 relative frequency, while the lowest was from Murraya paniculata, Bambusa vulgaris, and Molotus philippinensis, having a relative frequency of 57.143. In the computed density value, Travelus asper got the highest density of 0.0816. Bambusa vulgaris obtained the lowest density with only 0.0016. For the computed relative density, Travelus asper has the highest relative frequency, which is 5.231, while the Semicarpus cuneiformis got the lowest relative density of 0.0308. In terms of dominance of the forest trees, data show that Travelus asper was the most dominant among the 8 forest trees present in the study area of the northeastern slope of Mount Arayat, having a dominance of 1.428. The least dominant was Bambusa vulgaris, having a computed value of 1. For the relative dominance, Travelus asper obtained again the highest computed relative dominance of 135.23, while the lowest computed relative dominance was attained by Bambusa vulgaris, having a value of 94.554. In the computed importance value of forest trees, found the study area of northeastern slope of Mount Arayat, Travelus asper attained the highest importance value of 425,968, while the lowest was attained by Bambusa vulgaris, having a computed value of 151.8. Moreover, the computed species diversity of all species was 0.79. Table 2.1 clearly showed the computed population diversity analysis of forest trees present in the northeastern slope of Mount Arayat in terms of seedlings. Among the 8 species of the forest trees that were identified and classified in the research, Travelus asper and Nucaina leucocephala obtained the highest frequency of 0.6, while Murraya paniculata got a frequency of 0.4. Semicarpus cuneiformis, Kleinhobia oscita, and Samanea salmon obtained the lowest frequency of 0.2. The highest relative frequency was attained by Travelus asper, having 218.182 relative frequency, while the lowest was from Semicarpus cuneiformis, Kleinhobia oscita, and Samanea salmon, having a relative frequency of 57.143. In the computed density value, Nucaina leucocephala got the highest density of 0.3216. Kleinhobia oscita obtained the lowest density with only 0.0016. For the computed relative density, Nucaina leucocephala has the highest relative density, which is 6.2325, while the Kleinhobia oscita got the lowest relative density of 0.0308. In terms of dominance of the forest trees, data show that Nucaina leucocephala has the most dominant among 8 species present in the study area of the northeastern slope of Mount Arayat, having a dominance of 1.6069 The least dominant was Samanean salmon, having a computed value of 1.0002. For the relative dominance, Lucina leucocephala obtained the highest computed relative dominance of 180.0649, while the lowest computed relative dominance was attained by Samanea salmon, having a value of 112.0797. In the computed importance value of forest trees found the study area of northeastern slope of Mount Arayat, Lucina leucocephala attained the highest importance value of 404.4794, while the lowest was attained by Samanea salmon, having a computed value of 184.9007. Moreover, the computed species diversity of all species was 0.37.
Distribution and occurrence of forest trees present in the northeastern slope of Mount Arayat being affected by altitude, humidity, and air temperature. Table 3 shows the distribution and occurrence of the forest trees being affected by various ecological factors. Strabelus aster was present in all the plats. It thrived at an altitude of 74.6 meters above sea level, while the dry and wet temperature reached to 29 and 24 degrees Celsius respectively, and the humidity, on the other hand, reached up to 78.84. Muraya paniculata was present in Plat 1. It thrived at an altitude of 73.33 meters above sea level, while the dry and wet temperature reached to 27.33 and 24.66 degrees Celsius, respectively, and the humidity, on the other hand, reached up to 77.34. China leucocephala was present in Plat 2 and Plat 4. It thrived at an altitude of 74.66 meters above sea level, while the dry and wet temperature reached to 28.83 and 26 degrees Celsius, respectively, and the humidity, on the other hand, reached up to 80.5. Bambusa vulgaris was present in the mean plat. It thrived at an altitude of 74.33 meters above sea level, while the dry and wet temperature reached to 28 and 24.66 degrees Celsius, respectively, and the humidity, on the other hand, reached up to 76.72. Molotus philippinensis was present in Plat 3. It thrived at an altitude of 76 meters above sea level, while the dry and wet temperature reached to 28.33 and 26.33 degrees Celsius, respectively, and the humidity, on the other hand, reached up to 78.42. Carpus cuneiformis was present in Plat 2 and Plat 3. It thrived at an altitude of 77.8 meters above sea level, while the dry and wet temperature reached to 28.33 and 26.33 degrees Celsius, respectively, and the humidity, on the other hand, reached up to 78.44. Plainhopia hospita was present in Plat 2 and Plat 3. It thrived at an altitude of 77.8 meters above sea level, while the dry and wet temperature reached to 28.33 and 26.33 degrees Celsius, respectively, and the humidity, on the other hand, reached up to 78.44. Further studies on the different forest trees should be undertaken on the other parts of Mount Arayat to find out if there are same species found in the northeastern slope will also be present and if other species can also be found. Further, studies on the systematic and diversity on other forests or mountains in the Philippines can be done to find out if there are species of forest trees endemic on the area and compare the distribution and occurrence of these plants in Mount Arayat. A continuous monitoring of the population of the different forest trees found in the said area should be undertaken to avoid extinction of the species.
Conclusion: 80 species from different family are found in the study area. Muraya paniculata, Malotus philippinensis, Semicarpus cuneiformis, Strabulus asper, Leucaena leucocephala, Samanea saman, Plainhovia hospita. Each species were different in terms of shape, of leaves, leaf arrangement, leaf color, and leaf attachment. Strabulus asper obtained the highest frequency, relative frequency, relative density, dominance, relative dominance, and importance value since this plant occurred in all plants of the study area. Because the existing environmental condition, like in altitude, humidity, air temperature, soil pH, soil moisture, are within the range where S. asper can survive.